In this recording, we describe some other type of motion, what we call free fall. First, what do we define as free fall? We define as free fall, and we say that an object is in free fall whenever the only force acting on that object is gravity, the gravitational force. It does not matter if it is going up or down, sideways or not. All what matters is that the only force acting on it is the gravitational force. Now, whenever an object is in free fall, its acceleration is always 9.8 meters per second squared in the downwards direction. We are talking here, of course, objects in free fall at the surface of the Earth. We are not talking in general in astronomical scales and so on. So again, as I repeat, an object is in free fall when the only force acting on it is the gravitational force. It does not matter if it is going up or down. All what matters is the only force acting on it is the gravitational force. And then its acceleration is 9.8 meters per second squared downwards. Let's take an example, describe a few examples. For example, if I take an eraser and toss it towards a friend of mine, then, no matter what path that eraser is going to follow, if the only force acting on it is gravity, it's the gravitational force, the minute it is off my hand, that's important. When it is on my hand, there are other forces acting on it. Me. The minute it is off my hand, and just before my friend touches it, it is in free fall. I toss something upwards. The minute it is off my hand, if the only force acting on it is gravity, what do we mean the only force acting on it is gravity here? We mean we ignore the effects of air resistance. If the only force acting on it is gravity, the minute it is off my hand, and before it touches anything else, it is in free fall. It is in free fall while it is going up. It is in free fall while it is going down. It is in free fall from the instant it is off my hand till the instant before it touched anything else. If I throw something downwards, again, if we ignore air resistance, if we ignore the effects of air, the minute it is off my hand to just before it touches anything else, it is in free fall. Because then the only force acting on it is the gravitational force. So when do we have free fall on Earth? First, when we have no air resistance. In vacuum. We can do that in labs. I'll show a video in a little bit where we have something in free fall, in vacuum. Now, in real life, outside laboratories, it's going to be difficult to find a situation where there is no air resistance. But the effects of air resistance are sometimes going to be so small to take into account. For example, dropping a billiard ball, the motion of a billiard ball is not going to be affected very much while it is in free fall, while it is falling, by air resistance. And we can easily say it is in free fall. It is approximately in free fall. However, if we drop a feather, it's a different story. Air resistance is going to play a major role, and it's not in free fall. In other words, In most cases, the effects of air resistance in the falls of objects can be ignored, and we can say we have an approximate free fall, or we have free fall. Okay, and when is that going to happen? When we drop objects, when we throw objects. It does not matter if we drop them downwards, if we throw them downwards, upwards, or at an angle. Whenever the object is off the device that's going to be doing the drop-in or throw-in, whenever it is off the device, and before it touches anything else, that's the key. It is in free fall.